Hello everyone, and let's look at one of the problem from Geeks for Geeks. It says Kadane's algorithm or Kadane's algorithm, whatsoever you wanted to say it. But the gist is pretty simple that we are given an integer array and we need to find a continuous subarray containing the maximum sum. So the array, subarray for that matter, can have at least one number as well. So with that in mind, let's see at few of our examples. So we have first example over here. It says 9 within the subarray because we took 1, 2, 3, minus 2, although it might seem contradictory, but hold on for a while, and ultimately we took 5. So including all the elements within the array, which is also a subarray, we got the maximum sum. We also have second example where we have took only the first element because taking the rest can degrade our sum. And here goes the third, because everyone is positive we can take entire thing. You see, if arrays contain only positive, then we can take any number, but it has negatives, and it has negatives in such a way that we neither cannot ignore them or we neither can take them blindly. So we need to have a proper mechanism in that way. So how do we deal with this? You see, we are talking about subarrays. How do we define a subarray? So subarray is something that has a start and an end. So if we have a definite start and definite end, we can get through the array. So one might say, hey, why don't we do one thing? So let's go ahead. Let's take this one as start, 2 as end, 1 as start, 3 as end, 1 as start, this one as end, so on. Likewise, we'll go till the end. We'll contain that within, we'll store it somewhere just to track the maximum count, and we'll do the same with start as index 1, we'll do the same with start as index 2, 3, and so on. Likewise, we are sure to get the maximum number or maximum sum. But hold on for a while. What do you think, how many iterations would it take? Or in other words, what would be the time complexity of that operation? So permutation of start and end would take approximately O of n square time complexity. So n into n, that is not very good. And we can solve this within the expected time complexity of O of n. So why settle for the cheaper option? But how do we solve it within O of n? You see, our concern with the first approach was the iteration. We wanted to change start and end so that we can keep track of maximum. So I'll write here so that we can keep track of maximum sum. And we go ahead from I, or I would say start, from 0 to n, and end, which could be in the fashion of the same, like start to n. So even n can be written as a function of start. So why do we have two iterations? Why can't we do with one? So you see, how do we do this with one then? So you see, like we have 1, if we add this within 2, we got 3, and we still add it, minus 2. So till this moment, 1, 2, 3, we had a sum. Let me catch it down over here. Okay, this is our array. So at this moment we had 1, at this moment we had 3, at this moment we had 6, but as soon as we go ahead with minus 2, we had 4. We go ahead, we reduce our maximum sum, or let's say for that matter current sum, by incorporating minus 2, but we are still within a chance that let's see what happens when I take minus 2 into consideration, what happens when I take 4 within the sum or current sum. No doubt our maximum sum would be 6 because we have found 6. So as of now it's pretty clear we need to have maximum sum and current sum. So once we have 4, Let's check with 5. So if it was 5, then we would get 9. Oh, my bad. Then it would be have 9. So that's good. So our maximum sum instead of 6 would have been 9. And that's good. But let's suppose for an instance it was not 5 but it was minus let's say 3. In that sense, shall we go ahead, shall we do something like 4 minus 3? What is 4 minus 3 is 1, and still we had a maximum sum as 6. So there is no loss or no harm in taking minus 2 into consideration, but it is limited to this example. Let's suppose we have another example of the fact that I'm having minus 6 here. So in that case, if I'm using here minus 1 and minus 6, then I'll go ahead and I'll write here that my total sum would be minus 5. Right? Right. Still our current sum is minus 5 and our maximum sum is 6. But now here comes a twist. Let's say I have 10,000. If I still take minus 5 and I went ahead, so would it amplify or would it add any value to my next element? The answer is no, it won't add any value. In fact, it would subtract a value from my existing element. So what I would do is, whenever I've encountered minus or negative value, I will not even include it. So I'll just mark it as don't include, and instead of don't include, take 0. And when I took 0 and I saw this next element, I'm sure to get this value. Good. You can also try it with removing minus 6, then you'll get 1001. Our intuition or our logic still applies good, since by removing minus 6 we are still with 1, and if I add 1 to 10,000 it's 10,001, a very good palindrome number, and that's also our result. So without any further ado, if our logic is good, let's get started into code and we'll have a better understanding. So jumping into code, we'll just go ahead and first make the space where we can code. We have an array A, and we will just go ahead and check if A is null or A is empty. Then we throw an illegal argument exception, throw new exception null or empty array. Well, that is with us, and now if the control comes over here, we are sure that A is not null or neither A is empty. So what would we do? We'll iterate one by one A elements. So I is less than a dot length I plus plus. We'll also have two things, which would be max sum and current sum. So it will be max sum, which initially would be A of 0, and int current sum, which would be A of 0 for that matter, but who cares, I'll use 0 because current sum would go ahead and add A of I. Good. Now if we have maximum sum and current sum at our place, so we'll check if current sum is lesser than 0, then current sum is equal to 0, and we'll go ahead for max sum is equal to math.max max sum of its previous value or any upcoming value. How would we find upcoming value? By adding the existing element. Existing element is A of I and 1. So addition of this is within the current sum. So current sum, as this is the current sum, if you are So this is the current sum. It was earlier this current sum's earlier value, and it was the current element. So current element added within current sum is 1001, as 1 plus 10,000 is 10,001. Max sum initially was 6, so it would be max of 6 comma 10,001. Cool. So this is how we have calculated max sum, and ultimately will return max sum. So we have it says semicolon missing in the end. Okay, we'll add a semicolon and we'll run this again. Okay, it runs with sample test cases. Let's submit it for rest of the test cases. Okay, it feels like a 0 is not an expected answer because we are checking initially. We should not check initially. 0 is not expected because they want one of the element from the array and not 0. So technically 0 is much greater than -1. So let's submit this now. So yeah, it passed all the test cases, and this is one of the very famous and very standard problem. As you can see that this has been asked in multiple interviews as well, and it helps within most of later problems as well. So that was all about it. It was and this marks a beginning of this problem is very vital because this marks a very beginning of dynamic programming. Instead of calculating all the states, we maintain the state. We maintain the maximum sum state and we maintain the current sum state. So this was all about it. If you wanted to know more about arrays, dynamic programming, click the video on your right, and I'll see you in the next one.